Now that we've practiced how to convert between different forms of numbers and we've talked about squares and square roots, we're going to use all that to compare numbers and to place numbers on a number line, at least approximately on a number line. So just some quick reminders. Less than is this sign, greater than is this sign. However, we really do need to be able to read an inequality both forwards and backwards. That way it makes more sense and we can use that in problems to help us quickly. So for example, 3 is less than 5 if I read from left to right. But if I read this from right to left and I start at the 5 and I read backwards, I would say 5 is greater than 3, which makes sense. We know that 5 is greater than 3. But that's because if I read this 5 first, and then as I'm going left, I'm seeing the open side, so that's why I would say greater than. So even though it's a less than sign, because of the direction I'm reading, I'm seeing the big side first. So 5 is greater than 3, 3 is less than 5. So this one problem can be read both directions, and we should be able to understand that both directions. This is, if we say less than sign, we do mean this sign. But it could be read forwards and backwards, and it switches it up. Okay, and then rounding. I'm not sure we'll have to do much rounding on this one, but rounding in general, we've had some struggles with. So 5 or more, we round up. And if it's 4 or less, it stays the same. So if I were looking at the number 2.78 and I wanted to round to the nearest tenth, so the 10th place would be here, the 7. To do that, you look at the number after it. If it's 5 or more, which it is, we round the number we're trying to round to up. So that would be 2.8. So you're always going to look at the number to the right of where we're trying to round to, and that's going to tell you, should I round that number I want up, or should I keep that number I want the same? And then you drop all the numbers after that. All right, so we're going to compare with less than, greater than, or equal to. So we can't really compare numbers when they're in different forms. And we're only going to look at 3 different examples, but there's so many different ways we could have different numbers we're trying to compare. This is just a few of the ones that I want to make sure I went over because they're a little bit different or because I've seen common mistakes on these. Either way, when we're comparing numbers, we want to get them in the same form. One of the easiest forms to compare is decimals, because we can easily compare those place values, especially because we are used to money, and money is to the hundreds place. Or whole numbers. Like this one, for example, 36/4 as a fraction, that's confusing, but if I think about it as a division problem, 36 divided by 4 is actually just 9. So we can simplify that a lot. And at first glance, we might say equal, but this says the square root of 9. And the square root of 9 means what times itself is 9. 3 times 3 is 9. So the square root of 9 is 3. So now we're really comparing 9 to 3. And 9 is greater than 3. So 36 over 4 is greater than square root of 9. So once we put these in the same format, which in this case happens to be whole numbers, it made it a lot easier to compare. Number 2. Here's a very, very common mistake. A lot of us want to look at this and say that we're comparing 12 to 4, and 12 is bigger than 4. But that is not how we compare. We can't compare 12 to 4 because they're not in the same place values. So we can compare this one of 2 ways. One way we can do this is we can make them both the same place value. So 12 goes out to the hundredths place. So we need to make this one go out to the hundredths place. I can do that by adding zeros because that won't change my number. So we're really comparing 7.12, or 7 and 12 hundredths, to 7 and 40 hundredths. And 12 is less than 40, so this would be less than. Another way that we can compare this is just to look at, since they both have tens place, they don't both have a hundredths place, but they do both have a tens place. So I could compare the tens place. 4 is a tens place here, and 1 is a 10th place here. And this 1 in the 10th place is less than 4 in the 10th place. So that's another way we can compare. But make sure you're always comparing place value to place value, equal place values. Number 3, we learned how to estimate square roots, and square root of 80 would fall between square root of 81, which is 9, and square root of 64, which is 8. We want these to always be consecutive numbers, so 8, 9. We wouldn't want 7, 9, or 6 and 9. So square root of 80 is between 8 and 9. And 80 is awfully close to 81, so it should be awfully close to 9. Maybe 8.8 or 8.9, somewhere in between there. If I really wanted to check, I could take 8.8 times itself, 8.8 times 8.8, and compare how close that number is to 80. And it would let me know if I need to adjust that number up or down. So we're comparing, and this is in the tens place, and this is in the tens place, so those I can compare now, and 8 is greater than 3. So then the square root of 80 must be greater than 8.3. We're going to do the same thing on this next one. We're going to convert them all to the same form, that decimal form or whole number, except we're going to put them on a number line this time. And actually by doing that is another way that can help us to compare. If you think about where would a number be on a number line, that can help you compare them, because the further to the left you go on the number line, the smaller, and the further to the right you get, the larger the number would be. So it can help you compare and decide which one's bigger or smaller by thinking where would it be on a number line. Okay, so 18 thirds. Well, 18 divided by 3 happens to be exactly 6. So 18 thirds would be exactly on the 6. 5 and 4/8. So if I reduce that down, that's 5.5. I could turn it into a decimal also. That's 5.5. Remember, we do decimals by dividing 1 divided by 2 or 4 divided by 8. It gives us 0.5. So 5.5, well, that's halfway between 5 and 6. So around here, that would be the 5 and 4/8. Halfway between 5 and 6 is 5.5. The next one, 2 plus the square root of 2. So similar how we did up here in number 3, we had to estimate that square root. I'm going to have to estimate this square root. So that will be between square root of 1 and square root of 4, and that's 1 and 2. And the 2 is closer to the 1 than it is to the 4. But halfway between there would also be not too much further from the 2. So maybe it would be 1.4. Again, we're estimating, so this is going to be just fine for an estimation. Maybe 1.3, somewhere around there. And we're taking 2 plus our estimation. So 2 plus 1.4 would be about 3.4. So I'm going to say about. That's what this line means about. So then on my number line, about 3.4 is around here. And that's a 2 plus square root of 2. So we estimated our square root, and then we did that addition, 2 plus our estimation, to get our new estimation. And then 8.8, that is going to be way over here, pretty close to the 9, is 8.8. Square root of 52, we're going to have to estimate this one again. I recognize that 49 is awful close to that, and that's 7. Then I need the bigger side of that is going to be 8, which is 64. So it's going to be between 7 and 8. And 52 is closer to the 49, so it's going to be closer to the 7. It's not too close, so maybe 7.3, 7.2, somewhere around there. And again, if you really want to check, you could do 7.3 times 7.3 and see how close that was to the 52. If it's too far away, I can try again and say 7.2 times 7.2. Or 7.4 times 7.4 and see which one gets me the closest to the 52. But right now we're going to say that's going to be a good estimation, 7.3, at least for what we're doing. So 7.3 is going to be around here, and that was the square root of 52. Notice on my number line I'm always putting back that original form, because those are the actual numbers that we are trying to order. And square root of 16 is exactly 4. Remember, square root means what number times itself, and 4 times 4 is 16. So exactly on the 4 is the square root of 16. So now we've placed all those numbers on the number line. If we needed to compare, for example, these two here, I could say that 2 plus square root of 2 is less than square root of 16. I know that because it's further left on the number line. Or here I could say that the square root of 52 is less than 8.8 because it's also further to the left on the number line. So we could also use a number line to help us compare numbers as well.